from the graph of a function, we need to be able to describe what is happening with the function in words. So first thing we want to do is go over some terminology. I've drawn a circle here, and basically if I take a look at this graph of this function, there are several shapes in the function that are represented on this circle. So what we want to do is we want to be able to discuss what the shape of a graph is we're looking at it from left to right. So first thing I'm going to do is go with the straight lines. If the graph is going straight downhill, we say that it is decreasing. And because this is a straight line, it is decreasing at a constant rate. For the horizontal line, we would say that the graph is constant. For the increasing straight line, we would say that it is increasing at a constant rate. Unfortunately, many of our graphs do not have these straight lines that make up the graphs. They have curves. So what we need to be able to do is identify which portion of these quarters of a circle, what they are doing. So first thing I want to look at is decreasing. That means the graph is falling from left to right. There are two areas where this graph is decreasing. There is this one and this one. So for both of these, they are decreasing. Except this one is decreasing at what they call a decreasing rate, because as you notice, if I were to put a tangent line along here, the slope of the tangent line is getting smaller and smaller and smaller. So we write decreasing at a decreasing rate. For this region, the slope of the tangent line is getting bigger and bigger in the negative direction, so we would say that this one is decreasing at an increasing rate. For the increasing function, that's going uphill from left to right. That is this region and this region, so these are both increasing. Notice here the slope of the tangent line starts out really, really steep and gets shallower and shallower, or less positive, so we would say that this one is increasing at a decreasing rate. This one right here, the tangent line going from left to right, gets more and more positive, so it's going up in value. So we would say this one is increasing at an increasing rate. One other thing that helps us when we identify graphs is the shape in this upper half we call concave down. So the upper half region is concave down. The lower half region we call concave up. And where a graph changes from a concave, where it's at the top in its concavity, where it changes from an increasing to a decreasing function, or at the bottom where it changes from a decreasing to an increasing function, these points right here are called relative, and if it's a top point, it would be called a relative max, and at the bottom point, it would be called a relative minimum. If a graph happens to have its relative max is at the overall maximum value of a function, then we would also call it the absolute maximum. If a function goes down to negative infinity, there is no absolute minimum because you can never get to negative infinity. Similarly, if a graph goes all the way up to positive infinity, there would be no absolute maximum because you cannot actually reach positive infinity. So what I want to look at is the graph of f of x equals 1/3 x cubed plus 3/2 x squared minus 4x. For the type of problems that you will be doing, you will be given a graph, or you'll be asked to graph a function in the graphing calculator or using Desmos, and then you want to describe various places on the graph. And when we describe these places, we want to give x values and or y values, which you will see. So the first type of question they ask is, where is the graph increasing? Where is the function increasing? So I can say that f of x is increasing wherever it is going uphill. So wherever it is going positive from left to right. So it's increasing from here up to this point, and it's also increasing from this point up to infinity. So we write our ranges in interval notation. So it's increasing from negative infinity all the way up to the x-coordinate of -4. And it is also increasing from the point 1 to positive infinity. Other questions that'll be asked is, when is the graph decreasing? I can say f of x is decreasing whenever the graph is falling from left to right, and it's going downhill starting when x is at -4 all the way to when x is 1. So my interval would be from -4 to 1. Notice that because it's changing from decreasing to increasing here and changing from increasing to decreasing here, I did not include the actual endpoints because it is not increasing at those points. Okay? Well, if it's not increasing and it's not decreasing at those points, we could actually say that the function is constant at those points. F of x is constant. And in this case, they're points, but if I had a horizontal line, I would give an interval. F of x is constant at the point -4, and it is constant at the point 1. Because they are single points, I have to reference them in set brackets. And that was at -4 and at 1. Other questions you'll need to be able to answer is, when is the graph positive? The graph is positive whenever the graph is above the x-axis. So f of x is greater than 0 on what interval? Well, it's greater than 0 at, and of course I wrote these points backwards, both of these. Okay, this should be -6.38, 0. So it's and 1.88, 0. So it is positive from -6.38 all the way to the x value of 0. -6.38 to 0, not inclusive because it's 0 at 0, so it's not positive there. And it also is positive from 1.88 to 0. So I'm going to union that with 1.88 and not 0. It goes all the way to infinity. Similarly, you may be asked when the graph is negative. F of x is negative whenever I'm below the x-axis. So the graph is negative from -infinity to -6.38. -infinity to -6.38. The graph is also negative between the x values of 0 and 1.88. You may be asked when is the function equal to 0, and that would be where it crosses the x-axis. So we would write f of x equals 0 at the 3 x coordinates where it crosses the x-axis, so -6.38, 0, and 1.88. And the final questions you may be asked is, where is the graph concave up And where is the graph concave down? Well, the graph is concave up from this point right here, which is called an inflection point, all the way up to positive infinity. So I'm just going to abbreviate it as concave up. C up from negative 1.5 to infinity. And it is concave down from negative infinity to negative 1.5. One of the activities we'll be doing in class is how to use the graphing calculator to find the relative maximums and minimas, how to find the zeros of a function from the graph. And if you take calculus, you'll also be able to find this inflection point. So if the inflection point is not given, you will not have to determine where the graph is concave up or concave down. And with all of our functions that we graph, you're going to probably be asked what is the domain of the function and what is the range of the function. Okay? Because this is a polynomial function, you should immediately know the domain. The domain is all real numbers. And again, we can check it is what x values actually can go into this function. Well, it starts out at negative infinity for x, and it goes all the way to positive infinity for x, and there are no holes or asymptotes in this graph. So it's negative infinity to infinity. And for the range goes down forever for the y value, which is negative infinity, and it continues up forever, which is positive infinity. So for this graph, the range would be negative infinity to infinity, or all real numbers. If you are asked to identify relative minima and relative maxima, well, there's a relative maximum because it's changing from increasing to decreasing. You can say that f of x has a relative max of, and then give me the value, 15.33, at, and then tell me what x coordinate, negative 4. Similarly, you can tell me where the relative minimum is. You can say that f of x has a relative min of, give me the value. Well, the value would be the y coordinate, which is negative 2.17, at, and then give me the x coordinate, 1. So these are all the different ways that you can verbally describe what is happening to a function.